Section 2.3, example 11b. Solve n minus 1p2 equals 12. So just to start off with our permutation formula, we have npr equals n factorial over n minus r factorial. So we're going to start n minus 1p2 equals 12. So we're going to take a look that this now is n, and this number 2 is the r position. So when we're going to use this formula, we take whatever is in this first position, n minus 1 factorial, divided by whatever is here, subtract whatever is here, n minus r. So on the bottom we have n minus 1 subtract 2 equals 12. We can simplify that denominator. N minus 1 minus 2 gives us n minus 3 factorial. And from here, we are now going to just rewrite. We ask the question, which is the larger number, n minus 1 or n minus 3? So n minus 1 is the larger number. We're going to start by writing out n minus 1. 1 less than n minus 1 is n minus 2. 1 less than n minus 2 is n minus 3. Okay, and from here we notice that now that looks like the denominator. So I'm just going to write n minus 3 factorial all over n minus 3 factorial equals 12. We can see now that n minus 3 factorial on top can cancel with n minus 3 factorial on the bottom. Anything divided by itself is 1. We are left with n minus 1 times n minus 2 on top equals 12 on the other side. From here, we are just going to continue to multiply out to simplify this equation. We're going to take n and multiply it by n minus 2. And then we're going to take minus 1 and multiply it by n and minus 2. So we end up with n squared minus 2n minus 1n plus 2 equals 12. We can simplify that. Minus 3n, 2n, negative 2n, and negative 1, they are like terms that can be added together. This is a quadratic equation that we're solving. It's a quadratic because we have an n squared. So the first thing that we're going to do when we have a quadratic is to get equals 0. So I'm going to get rid of this plus 12 by subtracting 12, and whatever we do to one side, we do to the other. And so now 12 minus 12 gives us 0. Simplifying the other side, we have n squared minus 3n minus 10. So now we're going to finish solving. We have to factor this trinomial. We're going to factor by using sum and product. So we need a sum of the number in front of the n. So we need a sum of negative 3. And we need a product of that constant term at the end. So we need a product of negative 10. So the question is, what two numbers, when I add them, gives me negative 3, and using the same two numbers, when I multiply them, gives me a negative 10. So starting with the product, two numbers multiplied together to give negative 10. 2 times 5 will give us positive 10. So to get a negative 10, one of those numbers need to be negative. Looking at our sum, Again, when we add those two numbers together, we need a negative 3. So that means we need a negative 5. 2 plus negative 5 is negative 3. 2 times negative 5 is negative 10. So the two numbers that work here are 2 and negative 5. So those are the numbers that go into our two binomials. We have n plus 2 and n minus 5. When we multiply those together, it gives us n squared minus 3n minus 10. From here, we are using our zero product property that says if we multiply two things together and it's equal to 0, then one of those numbers have to be 0. So we conclude that this factor of n plus 2 is 0, or the factor n minus 5 is 0. Solving each of those, solving for n, so in this case, subtract 2 from both sides, we end up with n equals negative 2. This case, we have to add 5 to both sides to get n by itself. N equals 5. And one last piece here is that we are solving for n in a permutation. That restriction tells us that n has to be a positive number. So this, finding a value of n equals a negative number, we have to reject that solution because n cannot be negative. Therefore, our solution is n equals positive 5.